Okay, guys, so now we're going to do problem 4, last video. All right, so a man walks along a sidewalk. He travels with velocity shown on the graph. The three segments of the graph are labeled A, B, C. So if we look over here to our graph, what we're going to see is I've got a man walking down the sidewalk, and this is velocity versus time. So this is not his position. He's not going downhill and then uphill or something like that. This is velocity. So think about how his velocity changes when uh, when the lines change. Now, another thing I want to point out about this problem, okay, is that you guys are used to seeing velocity versus time like this. So you're used to seeing uh, a graph that has an axis in the middle and then a bunch of lines below also. All right, so don't get confused right now by the fact that there's nothing below this velocity versus time graph. It's all positive velocity, okay? So he's always going the same direction. He's always going away from zero. So don't think that downhill is negative velocity and uphill is positive velocity. It's all above the line right now. So here's what they want us to do. They want us to make a motion diagram that represents the man's motion. And it says, be sure to label all three segments of his motion. Don't forget to draw the acceleration vectors where they are appropriate. Okay, cool. So there's a lot to this. But first things first, I'm the realist. Let's make, we'll make our line for our motion diagram. Okay, now we're going to have three different segments of this. All right, so what I'm just going to go ahead and do, let's see. So the first segment is 7 seconds. The second segment is 5 seconds, and the last segment is 1, 2, 3, 4, 5, 6, 7, 8 segments. So my middle segment's going to be a little bit smaller, so I'm going to go about like that. Okay, now it says to label the segment, so I'm just going to go ahead and do that. So I'm going to say segment A, segment B, and segment C. All right, cool. So I've got my three segments labeled. Now I have to think about what's happening in each one of these. So A, his velocity is actually big at the beginning, right? It's 17 at the beginning, but then it decreases. So he's actually slowing down, okay, in this section. Okay, now B, it's flat, all right? So for B, flat means constant. And then for C, we see that it's going back uphill. So C is actually speeding up. Speeding up. Okay, so I need to reflect that in my motion diagram. I need to show that it's fast at first and then slows down. And then whatever that speed is here at the end, it stays that same speed all the way until the beginning of C. And then C, it speeds back up. All right, so let's see how we do this. So segment A, I know that it's going to be pretty fast to start with, so I'm going to space my dots out quite a bit. But it's got to slow down, so I want them to get closer and closer and closer. All right, so it's fast at the beginning. All right, my arrows are all going away from zero because remember, we're above the line. So my velocity is always positive. It's always moving away from zero. The length of the line is the only thing that's changing. Okay, now segment B, it's the slowest, so it's going to be the same interval. All right, and now notice that for constant, all of my lines are evenly spaced. Sorry, these are little now. Okay. It'd be easier if B was the fastest. All right, good. So now I've got a slowing down section. Okay, so slowing. I've got a constant section. I'm going to erase this, by the way, guys, so don't write slowing and constant in there. You don't have to do that. So I got my slowing down section. I got my constant section. And then the last part I need is my speeding up section. So speeding up, now my dots are going to start off close, and they're going to get a little farther, and a little farther, and a little farther, and a little farther. All right. So I'm going to go kind of like this. All right, so now I show it speeding up. My lines are getting longer. Okay, so I've got my slowing down, my constant, and my speeding up sections. So my dots are good, but I'm not done, okay? Because remember it says, so we labeled all 3 segments, that's good. But it says don't forget to draw acceleration vectors, okay? Where they're appropriate. So we need to draw some acceleration vectors on here. So when I look here, remember that my acceleration vectors always point towards the big arrows. Okay, so in segment A, slowing down means my acceleration is going to go against the current here. Okay, and I want all my acceleration vectors to be about the same length, which they're close enough. All right, so now my acceleration vectors are all going opposite of the direction. So remember, slowing down means that velocity and acceleration are opposite of each other. Now in segment B, I'm actually not even going to have any acceleration vectors because it's constant speed. So for constant speed, remember there's no acceleration, so no vectors are necessary. Now over here in segment C, my acceleration vectors should go with the lines because I'm speeding up. Okay, so I've got, that is the ugliest acceleration vector ever. That's a nice one. Okay. So I've got acceleration vectors going in the same direction. All right, good. So now my acceleration is great. I can see, so right here I can see slowing down, right here I can see speeding up, right here I can see constant. So that's what the motion diagram should look like when you go ahead and try that next one. I'm going to go ahead and erase all the stuff off of here because we're going to need to use this graph for the next part. All right. So the next part says calculate the man's acceleration for segment C. So remember that acceleration is VF minus VI over TF minus TI. So I'm going to go VF, VI, TF, TI. Now VF. Now we're looking at segment C. Okay, so let's get in close here. All right, so what I'm going to do is I'm going to draw, so I start off here. That's my initial position. So that means that here is TI. Here is VI. All right, let's use a different color, red. I see that here is TF, my final, and here is VF. Okay, so if I look at what these things are, what did I want first? I wanted VF first. All right, so VF looks like it's 10, 11, 12. All right, so VF, oh man, 12. All right, VI is 5. Okay, TF looks like it's 20. And TI is 12. All right, so I've got all my stuff. Let's plug in. All right, so VF was 12 minus 5, and then I've got 20 minus 12. So that's going to be 12 minus 5 is 7, and 20 minus 12 is 8. So I've got 7 meters per second over 8 seconds. So I'm just going to go ahead and go to my calculator here. So I'm going to go clear, and then 7 divided by 8 equals 0.875, so we'll call it 0.88. we'll say that it is 0.88 meters per second squared. That's my acceleration. Nice. All right, guys, that's it. Get to work.